Hello, I hope you are doing good. But still, are you struggling to remember the trigonometric equation? If yes, then don't worry. In this video, I am going to explain the tricks to remember the trigonometric equation using the super hexagon technique. Keep watching. We all know that the trigonometric functions are sine function, that is sine x, cosine function, that is cos x, tangent function, that is tan x, cosecant function, that is cosec x, secant function, that is sec x, cotangent function, that is cot x. Here x means angle. Now let's divide these functions based on the first letter. The functions start with the letter cr, cos x, cosecant x, and the cot x. The functions start with the letter SR, sin x, and secant x. The letters start with the letter TR, tan x. Now, let's draw the hexagon and place the trigonometric function on the hexagon. First, the trigonometric function with the letter T will be placed at the top, that is tan x. The trigonometric functions with the letter S will be placed at the top right and the top left. That is sin x at the top right and secant x at the top left. Now, the trigonometric function with the letter C will be placed at the bottom right and the bottom left. That is cos x at the bottom right, cosecant x at the bottom left, and the cot x at the bottom. So let's see one more time. Draw the hexagon, and now we will place the trigonometric function with the letter t at the top, that is tan x. Then the trigonometric function with the letter s will be placed at the top right and the top left, that is sin x at the top right and the secant x at the top left. Then the trigonometric function with the letter C will be placed at the bottom right and the bottom left. That is cos x at the bottom right, cosine x at the bottom left, and the cot x at the bottom. So now let's derive the equation using the super hexagon tricks. The first trick is select any three identities in the clockwise direction. So select the any three identities in a clockwise direction consecutively so that the first element is always equal to the second element divided by the third element. Therefore, we got that is tan x is equal to sin x divided by cos x. Similarly, for the next set of three elements, we will get sin x is equal to cos x divided by cot x. For the next set of three elements, we get cos x is equal to cot x divided by cosecant x. For the next set of three elements, we will get cot x is equal to cosecant x divided by secant x. For the next set of three elements, we got cosecant x is equal to secant x divided by the tan x. For the next set of three elements, we got secant x is equal to tan x divided by the sin x. Here, similarly, the things will be also hold good for the anti-clockwise direction. That is for the trick 2. The trick 2 is select the any three identities in the anti-clockwise direction. So from that one, we can say that tan x is equal to secant x divided by cosecant x. For the next three elements, we will get it secant x is equal to cosecant x divided by the cot x. For the next set of three elements, we will get is cosecant x is equal to cot x divided by cos x. For the next three elements, we will get cot x is equal to cos x divided by sin x. For the next set of three elements, we will get it cos x is equal to sin x divided by the tan x. For the next set of three elements, we will get is sin x is equal to tan x divided by the secant x. Now, the third trick is product method. Here, select any three consecutive elements from the hexagon and it will be the middle element is always equal to the product of previous element and the next element. So that will be we will get sin x is equal to cos x into tan x. Similarly, for the next set of three elements, we will get is cos x is equal to sin x into cot x. For the next set of three elements, we will get is cot x is equal to cos x into cosecant x. The next set of three elements we will get is cosecant x is equal to cot x into secant x. For the next set of three elements, we will get is secant x is equal to cosecant x into tan x. For the next set of three elements, we will get is tan x is equal to secant x into sin x. Now, the trick 4 is upward arrow, that is 90 plus, we will call it. This is applied diagonally upwards. If you apply this diagonally upwards, we will get the equation such as cos x is equal to sine of 90 plus x. And we will get is cot x is equal to tan of 90 plus x. Cosecant x is equal to secant of 90 plus x. Similarly, the trick 5 is downward arrow, that is 90 minus. This is applied diagonally downward and we will get the equation such as sin x is equal to cos of 90 minus x. Tan x is equal to cot of 90 minus x. Secant x is equal to cosecant of 90 minus x. So here we are looking at the 5 tricks. Now we will go to the sixth trick, that is arrow towards the center. Here we have to place the number 1 at the center of the hexagon and let point out the arrow towards the center diagonally so that we will get this equation, that is tan x into cot x is equal to 1 and cos x into cosecant x is equal to 1 and last is sin x into cosecant x is equal to 1. Now the trick 7 is arrow passing through the center. Here also let the number 1 be at the center of the hexagon and the arrow passes through the center diagonally so that we will get the equations as tan x is equal to 1 by cot x and cot x is equal to 1 by tan x. Sin x is equal to 1 by cosecant x and cosecant x is equal to 1 by sin x. Cos x is equal to 1 divided by secant x and secant x is equal to 1 divided by cos x. And the trick number 8 is clockwise within the squaring region. Here also let the number 1 be at the center of the hexagon and we will take the triangle as the squaring region and it should include the elements such as the center element 1 and the other two trigonometric elements. For writing the equation, the elements in the squaring region should be fixed and considered in a particular direction, that is first downward and then diagonally up left, so that considering the first set we will get the equation sin square x plus cos square x equal to 1. For the next set of elements we will get it 1 plus cot square x equal to cosecant square x. For the next set of elements we will get is tan square x plus 1 equal to secant square x. Similarly, For the trick 9 is the anti-clockwise within the square region, which is the same one, but within the square region, here we are considering the anti-clockwise. In this trick number 9, let the 1 be at the center of the hexagon, and here also we are considering the triangle as the squaring region, and which it should include the center element 1 and the true trigonometric elements. And for writing the equation, so elements in the squaring region will be considered in this direction. That is, first diagonally down right, then up we are being considering. So considering the first set, we will get it 1 minus cos square x equal to sine square x. Next, for the next set of elements, we will get it cosecant square x minus cot square x equal to 1. For the next set of elements, we will get it secant square x minus 1 is equal to tan square x. So now let's revise. From the trick 1, that is clockwise direction, we got these equations. And total number of equations is 6. From the trick 2, anti-clockwise direction, we got these equations. And total number of equations is 12. From trick 3, that is product method, we got these equations, and total number of equations we derived is 18. So from trick 4, upward arrow, we got these equations, and total number of equations is 21. From trick 5, that is downward arrow, we got these equations, and total number of equations is 24. From trick 6, the arrow towards the center, we got these equations, and total number of equations we derived is 27. From trick 7, arrow passing through the center, we got these equations, and total number of equations we derived till is 33. From trick 8, clockwise within the square region, we got these equations, and total number of equations we derived till is 36. From trick 9, anti-clockwise within the square region, we got these equations, and total number of equations is 39. So we can easily remember 39 trigonometric equations using this super hexagon technique. Do you like it? If yes, so kindly like the video, share the video, and subscribe to the channel for the more interesting educational videos. If you have any suggestion, please write it in the comment box. Have a wonderful day.